Welcome back. Let's see here. Today we are going to be starting electricity. We're just going to be taking a look at electricity. We're going to take a look at a few simple things. We're just going to ask ourselves what are volts, what are amps, what are ohms, and how do they work together in Ohm's law. Then we'll go ahead and we will do a little practice problem just to go along with that. All right, so volts. We're obviously talking about electricity today. We're going to be starting out with volts. Now, volts is the push in electricity. Volts is how much electricity wants to get from one place to another place. The stronger that push, the stronger the voltage. Okay, so think about different batteries. You got your normal like AA batteries and stuff like that. Here's a rough little AA. AA batteries run at 1.5 volts, okay? That's how much push electrons want to get from this side to the other side of it. Now, obviously there's going to be something in between there, like maybe a light bulb or something like that, but it's the voltage, the push. If you think about those nice little square batteries or rectangular batteries, I guess would be better. Now, I'm not suggesting you do this, but I always, when I was a kid, test them just by licking them. Just lick them and see how much electricity wants to get from one electrode to the other. Now, these are generally called 9-volt batteries. They have more push from one area to the other area. And then you have your wall outlets. Now, this is in America, and so our outlets look something like this. Okay, there is two of them, of course. The America normally runs at 120 volts, so that's going to be much more push, trying to get electricity, trying to get from one side right through your appliance back into the other side. Now, should be noted that we can sometimes wire stuff, such as, welders and stuff like that, wire it into 240 volts. I'm thinking RV campers can do that too, but normally normal wall outlets that we're used to seeing run at 120 volts. So the volts is the push. The amps, that's actually the number of electrons. That's how many electrons are getting from one place to another. That's how many electrons are going from this terminal all the way around to that terminal. Now, I think I might have this backwards. I think if you are being technical, I think the electrons actually leave this side of the battery and go to that side. But as long as you understand that amps is the number of electrons that are passing a point, that's what's important to understand the amps, okay? Now, it should be noted, volts do not directly hurt you. A normal shock, like you touch a doorknob and you get a shock from it, that's going to be around 40,000 volts. Amps are what are dangerous, okay? The more amperage, the more danger you are in of electrocution, okay? So all of those signs out there that say danger high voltage, they're actually kind of lying. That means there's a lot of push there, but it really should say danger high amperage, or there's a lot of electrons here ready to flow through your body, okay? Ohms is, I gotta back up here. Volts is sometimes abbreviated as E, okay, and I think that has to do with electricity or electrons, or energy would probably be a better abbreviation for that. Amps is sometimes abbreviated as an I. I have no idea why they abbreviate amps as an I, but that's just what I've seen in the past. Ohms is something completely different. Ohms is often abbreviated as R, okay, and I think that stands for resistance, or this one I like a whole lot more. I guess it's called the omega symbol, the Greek alphabet letter. It looks like an upside down horseshoe. That's also used quite often as a symbol for ohms. Now, what are ohms? Ohms are the resistance. Ohms is how much something is slowing down electricity. A normal copper wire is going to have basically no ohms. It's not going to slow the electricity down at all. But something like a light bulb or an appliance or something like that, that is going to slow the electricity down. As the electricity has to go and force its way through that wire and giving out heat and light as it does so, that's going to slow the electricity down. Okay, if you've ever blown a breaker in your house, that would be a time when you have no ohms. That's just when electricity is running from one side of a plug to the other side of a plug. There's nothing slowing it down, and at that point you're in danger of, you're running so much electricity through your wires, you might end up, setting your house on fire or something like that. Basically, it's just a dangerous situation, and that's why your breaker blows. It's basically so that you don't hurt your house. So ohms, make sure you understand ohms is the resistance or anything trying to slow down the flow of electricity. Now, these can all go together in Ohm's law. Ohm's law can be summarized as this little, I guess you call it diagram, this little symbol here, E, I, and R. Now, from this, we end up with three different formulas. We can say E equals I times R. So your voltage is your amperage times your resistance. You could also say your resistance is your voltage divided by your amperage. So resistance is E over I. Okay, and you can use the symbol to figure out the last formula as well, which is I, or amperage, is your volts divided by your resistance. Your volts divided by your resistance. Okay, so that's Ohm's law right there. I'm going to go ahead and try this practice problem real quick. If you want to, you could definitely pause and try it on your own as well. But I'm just going to say headlights on my truck, they pull 6.6 amps, and they have a resistance of 1.9 ohms. Okay, that's how much the headlights are slowing down the electricity. And this is basically, it's not 6.6 electrons flowing through, but this is 6.6 amps. This is 6.6 big bundles of electrons that are going through. Okay, what type of battery should I put in my truck? We're just going to pretend, okay, I got the amps and I got the ohms. We're just going to look for the voltage. Okay, so to get this, I'm going to use the formula. Now, all these formulas I showed you in Ohm's law can be rearranged, but E equals I times R. Voltage is amperage times resistance. So let's look for the voltage. Its amperage is going to be 6.6 amps times the resistance. The resistance is 1.9 ohms. You multiply those two things together and you get roughly a 12 volts. So I should put a 12 volt battery into my truck, and luckily all the truck batteries, or the car batteries I see at Auto Value, they're all 12 volts. Okay, now you can get different voltage batteries for different things, like I think most jet skis run off of a 6 volt battery, and so obviously that's going to change these numbers here. So hopefully this helps you understand electricity just a little bit better. Thank you. Have a great day. Bye-bye.